Assalamualaikum warahmatullahi and good day everyone. In this video we are going to focus on the chain rule. So for the chain rule, what happens is that we are going to use chain rule whenever we have a two function that is actually in one terms. Okay, so basically we have encountered this kind of equation before, and we actually solve it by not using chain rule. So basically a more proper way in differentiation, right, for this kind of case is by using chain rule. And for chain rule we actually use this formula, which is dy over dx is equal to dy over du times with du over dx. So we're going to see how to define each of these terms in order for you to calculate for the dy dx later on. Okay, so let's look at example, the first example, which is A. Let's look at this question. So as you can see, we only have one terms in this question, right? One term. But in this one term consists of two functions, if you can look at it closely. So we have a cos, usually cos x, right? Cos 2x. So now we have cos and the x being substituted with another trigo function. So basically the outer function, right, the function outside is a cos function, and we have another function inside the cos function, which is this sed sin x plus 1. So when we have this kind of situation, the more proper rule to the more proper technique that we can use to solve it is by using chain rule. Okay, so how to use chain rule? Remember again, the formula of chain rule is in finding dy over dx, alright, we need to multiply dy over du times with du over dx. Now, talking about this formula, we already used dy over dx a lot, and we clearly know that to get the differentiation of dy over dx, the equation or the function must be in terms of y equal to x, right? Like this one. Okay, so basically if we can directly differentiate this function, you will get dy over dx. Now they want us to find dy over du times du over dx. So basically dy over du tell us that we need to look for a function that consists of y equal to some equations in terms of u. Hence, when we do the differentiation, you will get dy over du. The same goes for this one, right? The differentiation of this one is du over dx. So basically the function the differentiation need to come from a function in terms of u equal to some equation that is in terms of x. So how do you find this? It's not being given, right? So we will need to develop this two function out of this main function. That is the initial part before conducting calculation for chain rule. So how to do it? So basically in chain rule, we always define a new we always define an inner function in another simpler terms. So for this case, right, the inner function of square root of sin x plus 1, right, is can be defined into another terms. So we can say let u equal to the inner function, which is set of sine x plus 1. Or to make it better, we can change it into the form that can make us easy to differentiate later on, which is sine x plus 1 over 2. Okay, so we have defined u. So when we have defined the sine x plus 1 square root as u, basically what we did is actually we have changed the original function into the terms of y and u. So hence it's become y equal to cos u. Right? Can you see it? Because we have defined this all as u, so we change it into u. Right? So I don't know if you realize it or not. So at this point, we have actually defined all of the function that we need to differentiate to get this. So let's check. Do we have dy over du, or a function in terms of y equal to u? We do. What about du over dx? U equal to x. So we have u equal to sine x. So we can use this to get this. So without further ado, let's look for dy over du. So dy over du equal to cos u, differentiate it, become negative sine u. Okay, and then we have du over dx. So du over dx. Now if you look at u and x here, okay, at a glance you might think that we'll need to do maybe another chain rule, right? Because we have the outer function of 1 over 2 and inner function of sine x plus 1. So inner outer function, you need to define another chain rule. But we have actually a properties or maybe a rule, right, in power rule that not being covered before. I did not tell you about it before, where we can directly differentiate it. If the function is simple enough like this, right, we can directly use that kind of power rule, which is we just going to firstly differentiate as usual using power rule, which is 1 over 2, right? We will put 1 over 2 in front, times with everything inside. Just write it back, and then the power minus 1, so we get negative 1 over 2. And then don't stop there. You are going, because we have another function inside, we are going to need to differentiate it and put it outside. Alright, multiply with it. So sine x plus 1 will become cos x plus 0. So let's just leave it at cos x. So this one will, if you try to simplify it further, we can see that it is actually we have cos times sine x plus 1 negative 1 over 2, yeah, and then this one is all will be over 2, right? And you can simplify it further. We can put because we have negative 1 over 2 here. First we have 1 over 2. We can change it back into square root, and then because we have negative, we can put it at the denominator. So we are going to have cos over 2. Right, as for this part, remember, we can change the 1/2 into square root, and the negative make it to the denominator. So it is actually can become square root, because of the 1/2 again, sine x plus 1. Okay, so this is its final form, final simplified form. So now that we have the two derivative, so next we can just multiply it together. So we're going to have negative sine u, or we can just expand it again. U is equal to what? U is equal to this whole thing we have defined before. So we can say negative sine times with the square root of sine x plus 1, okay, times with this whole thing. Okay, so there you go. So what's left is to put everything together. So we're going to have negative cos times sine square root of sine x plus 1 over 2 times square root of sine x plus 1. Okay, this is the derivative that we get based on the chain rule. Let's look at the next question. Okay, let's look at the second question. So for this one, again, we have one term, but inside that one term we have another term, right? So we have ln, inside that ln we have sine. So basically this make us need to use the chain rule. So let us first define the inner function as another term. So basically we can say let u equal to sine 2x. So basically when we have defined u, our y will become ln u. So with that, let's find the dy dx of the dy dx, right? So in finding dy dx, we will first need to look for dy over du, so which is this one. So we have dy over du equal to, from ln x it become 1 over x. So here ln u will become 1 over u. Okay, and we have dy du times with du over dx. So for du over dx, we are going to differentiate this part, du over dx is equal to sine 2x, which means that we have 2 times cos 2x. Okay, so let's try to find dy ds. Or before we do that, maybe we can expand the u so that later on we can just use it. So u here is equal to what? Sine 2x. So sine 2x. So to find dy over dx, it is equal to dy over du, which is 1 over sine 2x times with du over dx, which is 2 cos 2x. So this is equal to 2 cos 2x over sine 2x. So basically, if you calculate it, you can actually put this as the final answer. Even if you see in the in your books, they change this part into another triangle function because of its properties, but it is actually not crucial, not necessary for now. So you can just leave it like this. This kind of answer is also acceptable. So let's look at the next one. Okay, again, the sign of you need to use as a chain rule. Again, what? It is one terms, but it contains another terms inside. So we have inner outer function. Okay. So let's define the inner function first. Let u equal to x squared plus 5x plus 2, and then our y will become tan u. Alright, so with this we can look for du over dx, which is 2x plus 5. And for the second one, tan u, so dy over du will become secant squared u. And if we expand it, we can get it is actually secant squared, and u is all of this, secant squared of x squared plus 5x plus 2. Okay, so by this we can look for dy over dx, which is equal to dy over du, right, which is again secant squared of x squared plus 5x plus 2 times with the du over dx, which is 2x plus 5. So the final answer for its derivative simply 2x plus 5 times with secant squared of x squared plus 5x plus 2. Alright. Now this is all for the example. Let's look at the exercise. Okay, for the first exercise question. Okay, as you can see, we have the outer function of exponent with the inner function. Usually we have exponent of x, right? But now the exponent of x has become another function of trigo. So we have that as an inner function. So let us first define the u, the inner function. Let u equal 2 cos x plus 5x. And then our y will become exponent to the power of u. Okay, so now we try to differentiate du over dx equal to 2 cos x will give us negative 2 sin x plus 5. Before we proceed, if let's say you see that this one of the function that we defined is actually a bit complicated, maybe we can try to differentiate it alone and then put it in this part. Okay, if it is too complicated. So for this one we have dy over du, which is again exponent of u, remain unchanged. So if we expand it back, you will get the u, which is back at the same function, which is 2 cos x plus 5. Alright, so now let's find the dy over dx, which is equal to dy over du, which is exponent of 2 cos x plus 5 times with du over dx, which is negative 2 sine x plus 5. Right, so we can just simply put it at negative 2 sine x plus 5 times with the exponent of 2 cos x plus 5 as the final answer. So the next one. Now for this case, yes, we can see the outer function of power and also the inner function of polynomial. Okay, so you can use a chain rule, or if it is me, I will just proceed using the power rule that we discussed just now, right back then, which is we have 3 and then just copy everything inside. So x plus 2 exponent 3x to the power of 2 times with the function inside being differentiated, which is we have 18x to the power of 2 minus 2 cos 2x, and then plus with 6 exponent 3x. So this can be your final answer. Or if you think this is not that easy, you can proceed with a chain rule, right, which is by defining the u first, which is the inside here, and then do the dy dx equal to dy over du times du over dx, and then just rearrange everything and multiply. Okay, let's look at the next one. For the next two, actually this one is equal to 5x 5 minus 4x to the power of 3 plus 2x to the power of 1 over 2. So we can use the same way of the power that we discussed just now. The same goes for this one. You can use the idea of power rule, okay? Or again, if you feel uncomfortable to do that, you can use chain rule. Alright, so basically that is it for chain rule. Okay, so see you in the next video. Thank you.